Hello viewers on YouTube. In this video tutorial, we are going to consider some other brilliant ways in which problems can come on binomial expansions. Now, it is important to understand that, more especially if you are dealing with examination questions or your text questions, there's a high tendency that some of these problems might show up. So to understand how to handle those problems, it is important you get familiar with how to approach them, because these questions will be set with the hope that whenever you set them, you will know what to do. So let's consider the first one. Determine the fourth term in the expansion p plus 2q all to the power of 10. Now, judging what we are seeing on the board, what first comes to your mind? What do you understand by finding the first term of the expansion? Well, you already know what the term is. When we have something like 1, 2, 3, 4, 5, the first term can be 1, second term can be 2, like that. So the goal is that when we expand this binomial, what value is at the first term? That's what we are required to find. However, sometimes you might be dealing with a multiple choice question whereby you won't have more time to expand the entire binomial before you can now figure out the first term. So it is important you know how to get your answer in no time. So this should be your first approach. Kindly keep in mind that r plus 1 is equal to the number of times. So since it is 4 in this case, r plus 1 will be equal to 4. And by the time we subtract 1 from both sides, r will be equal to 4 minus 1, which is 3. So this is the value of r. Also, always be sure that whatever you have here as the power of the binomial, that is the value of n. Kindly keep that in mind. So in this case, n would be equal to 10. Now, it is binomial theorem we will consider using in all cases, as that is what we'll be using as a reference to how we can get our answer. Now, according to binomial theorem, the expansion of a plus b of a binomial to the power of n, which n can be any index, is equal to the summation from r equals 0 all the way to n combination r multiplied by a to the power of n minus r multiplied by b raised to the power r. Now, the fourth term of this expansion will now be when r is 3 and n is 10. So just plug it right into this value and get the fourth term, and they provide the answer to this example number 1. So in a case whereby you are asked to find a certain term, that will be your approach and that will be your steps. So therefore, the first term in this case right now would be equals to n combination r, which is 10 combination 3, r is 3, multiplied by the first term is p, so we have p to the power of 10 minus 3, that's n minus r, and then multiplied by the last term, which is 2q, to the power of r, where r is equal to 3. Now we can simplify this. What exactly is 10 combined with 3? 10 combined with 3 is 10 factorial divided by 10 minus 3 factorial multiplied by 3 factorial. 10 factorial can be simplified to 10 times 9 times 8 times 7 factorial. Why? 10 minus 3 factorial becomes 7 factorial, and 3 factorial can become 3 times 2. Now the 7 factorial can reduce this, and we have 3 to reduce 9 to 3, to reduce 8 to 4. So the product of 10, 3, and 4 results in 10 times 3 is 30, 30 times 4 is 120. So we have 120, p to the power of 10 minus 3 is 7. Now 2q to the power of 3 is simply 8q cubed. So the goal right now is to multiply 120 by 8. So 120 times 8, I will need to use my calculator for that. 120 times 8. So I got 960. So final answer in this case is 960, p to the power of 7, q to the power of 3. So this is the first term of the expansion p plus 2q to the power of 10. So I hope you find this helpful. This is how to easily find the value of a certain term given the binomial, regardless of what n is. So that's it. So now let's consider the second case. Find a term containing q squared in the expansion of p plus q to the power of 20. So this is another question. Then if you know what to do already, you can pause the video and figure it out yourself. Then after that, you can pause it and see if you have done the right thing. So the goal is to find a term that involves q squared. Keep in mind, don't mix it up with the previous question. That one, you have to find the value of a particular term. But right now, we want a term that has q squared. So they are entirely different. They are two different things. So how can we approach this question number 2? Now, earlier, if you could recall, I said that r plus 1 gives us the number of time. It gives us the nth time. So that's why we did r plus 1 earlier to be equal to 4, because we are required to find the value of the fourth term. Then we end up having the value of r to be equal to 3. So which means to get the term that we have q squared, we need the value of r. Now, if we have r, then life is easy. So how can we get r now? That's the issue. Now we are going to consider using binomial theorem. If you recall, we said for any binomial a plus b to the power of n, the expansion is the summation from r equals 0 all the way to n combined with r, the first term a raised to the power n minus r, then multiplied by the last term p raised to the power r. Now you can see p as the value of a and see q as the value of b. This implies that whatever index is attached to a, that index will be n minus r. Are we together? Whatever power you see that is attached to a, that power will be n minus r. And whatever power you see that is attached to b, that power will be r. Because that's how the logic works. That's the pattern for the entire expansion. So if that is the case, since p has been seen as the value of p, or as the value of b, then definitely, also since q has been seen as the value of b, definitely the power of q, which is 2 in this case, is the value of r. And if we had to find the index of p now, p would have been, the power of p would have been 20, that's n minus r. So that would be p raised to the power 20 minus r, and r we said is 2, that p will be 18. Keep in mind, the sum of the power of the first term, which is a, plus and the power of the second term, it will give you n, and 18 plus 2, which we said is the value of r, gives us 20. So that's the logic. So as n, as the power of a, or the first term, is decreasing by 1, the power of b, the second term, will be increasing by 1. And so and eventually their sum will be giving us the value of n. So whichever power you see with b is the value of r. Whichever power you see with a is the value of n minus r. Are we together? So therefore, our r is equal to 2 in this case. And with that, we can clearly say that the term that has q squared is the 2 plus 1 term. Is the 2 plus 1 term, which is 3. So the third term will have q squared. Now the other way in which you can solve this question is to expand. But unfortunately, sometimes they might not say you should find the term that contains q squared. They might say you should find the term that contains q raised to the power 18 or q raised to the power 15. Expanding, using the logic of expanding, that might take time, as you might be dealing with a multiple choice question whereby you might have limited time. But this process will give you your right answer in no time, and it works in all cases. So that's the solution to example number 2. On to example number 3. Find the coefficient of x raised to the power of 7 in the expansion 3x plus 1 over 2 raised to the power of 8. First thing first, it is important to understand what the coefficient is for this example number 3. You see, all these questions, they are entirely different things. Coefficient is a number that is attached to a variable in an expression. Take for instance 2x. The 2 is what we call coefficient, and x is what we call variable. A variable is a letter in an expression, while coefficient is a value that is attached to a variable. So it means we need a value that is attached to x raised to the power of 7 in the expansion of this thing. Now, to expand this binomial and get the coefficient, that is a good thing, but it's a time consuming. Can we just get it in no time? Yes, we can. Now, this is what you need to do. First, identify where that variable is in the binomial. Because you can see, x is at the first term of that binomial, and the other term is 1 over 2. Once you have done that, then you are on the right lane. Now, let's go back to binomial theorem. It says that when we have a plus b raised to the power of n, the expansion is simply the summation from r equals 0 all the way to n combined with r multiplied by a raised to the power n minus r, b raised to the power r. So this tells us that whatever comes first in that binomial, whichever index you see on it, that index is simply n minus r. I was get that, simply n minus r. And whatever index you see on the other term, that index is simply r. Now, since x tends to be at the first term, it means its index is simply the n minus r value. So clearly we can say that n minus r is equal to 7. However, n, we said, is the value of the entire index for that binomial. So it means n is 8, then we have 8 minus r equals 7. Then eventually, 8 minus 7 gives us the value of r, and r is equal to 1. Now that we have r and the value of n, it is very easy for us to get the coefficient of x to the power 7. So therefore, the coefficient of x to the power 7 will be 8 combined with 1. So a is what? 3x, the first time. So that will be 3x raised to the power, don't forget, n minus r is 7, raised to the power 7, then multiplied by, the last time, that's 1 over 2, so that will be 1 over 2 raised to the power r is what? 1. Perfect. So 8 combined with r, let's compute that. That will be 8 factorial divided by 8 minus 1 factorial times 1 factorial. So 8 factorial can be reduced or simplified to 8 times 7 factorial, and 8 minus 1 is simply 7 factorial. Then 1 factorial is gone, it's still 1. So this cancels. So that means 8 combined with 1 is simply 8. Perfect. So we can just reverse this. Okay, that will take time. Let me just get rid of it entirely. Oops. So we have 8 multiplied by 3 raised to the power 7. 3x raised to the power 7, that will be times 3 raised to the power 7 times x raised to the power 7 times 1 over 2 raised to the power 1, that's 1 over 2. So we just need to compute this value. So what exactly is 3 raised to the power 7? To get that, I need to use my calculator for that. So 3 raised to the power 7. So I got 2,187. So therefore we now have, this is equal to 2,000. Okay, we have times 8 first. That becomes 8 times 2,187 times x raised to the power 7 times half. So the half can reduce the 8 to 4. So we can just have 4 times 2,187 times 4. So we got 8,746. So therefore, the coefficient of x raised to the power 7 would be 8,748. Sorry. So we have 8,748 x raised to the power 7. So this is the coefficient of x raised to the power 7. So that value is what you will take, 8,748. So this is your answer. So this is how to easily approach this kind of question as well, and I hope you find it helpful. So these are the 3 different ways in which question can still come on binomial expansions. So I hope you find this helpful and understandable. Thanks for watching. See you in the next video. Bye for now. So I have an exercise for you, and here it is. So feel free to share your solution with me via the comment section below. Thanks once again. Bye for now.